All right, guys, we're going to talk about vertex form of a quadratic. And we talked about standard form before, but vertex form looks like this. It's where you have a set of parentheses. That set of parentheses is raised to the second power. What's key is that the variables is inside of there. So that's raised to the second power, makes it a quadratic. And some of this is review. Most of this is review. So let me just review it really quickly. The h in here, in fact, let me erase that and use red just so I can make sure I'm consistent. The h in here moves it left or right is just the opposite. And when I say move it, I'm talking about the vertex. We start off with the parent function. The vertex is right here. When we adjust it, we move it left or right using the h, and then up and down using the k. For the h, it's the opposite of what you think. So a negative would mean you move to the right. A positive in here would mean move to the left. I mentioned before that a, if it's positive, then it looks like the regular smiley face, the regular parabola, the upside, the correct version of the parabola. If a is negative, then it's flipped, and it's a downward facing parabola, downward facing u. The thing I want to add this time, though, is that when that number is different than 1, so if it's a -2 or a +2, when the number is bigger than 1, the graph is going to be skinnier. If it's less than 1, like a half or -1/2, something like that, it's going to get flatter and wider. We say that this right here is a stretch. So it stretches it by a factor. And this is a shrink, if you will. It flattens. It flattens it. All right, so if I were to look down here, my quick little example, if I start off with the parent function, this right here would tell me inside of here, would tell me to move right 1, the vertex, right 1, and then up 2. This one would say start with the vertex and move right 1, move up 2, but then this thing right here, because it's negative, tells me to flip it, which means it's going to go downwards. All right, let me take a look at this on here. So if I had x squared, just the parent function, if I were to change that, and let's just say I make it +2, notice that it moves to the left 2 like we expect. All right, if I do that again, and then I add 1, it not only moves it, but then it shoves it up 1. Right? Now if I do the same thing, add 1, and then put a -1 up there, and hit enter. Ooh, forgot the 1. Notice that it's the same vertex, but now it goes downwards. It's the same vertex as red, but now it moves downwards. All right, let me get rid of these other ones just so you can see. It's the same vertex as red, but it's downwards because it's the same thing except for the negative. All right, now what if instead of negative, I put a +3? Notice how the blue is a lot skinnier because when I look at -1 for the red, for example, -1 for the red gives me a value of 2. Now, if I go to -1 on the blue, you see that it's way higher than 2. It should be 4 because you multiply that amount and then add 1. So the value of the blue is higher. It's actually a factor of 3 higher, and so it's skinnier. That's what I mean by shrinking. Now, if I made this 1/3, notice that the blue would be fatter than the red. It flattens out some. That's what that letter A does. It stretches it or it shrinks it, and then you got to pay attention to whether it goes up or down. All right, so that's a very quick crash course. Most of that we've already done before, so I could ask you to graph this function very quickly or sketch it, and all you really have to do is move the vertex. Also keep in mind that since this is a function, if I just did a function table like I did with all the other ones like x and then f of x, I could find specific values when I plug in values for x. So that's always in play. But just as a quick little sketch, knowing the parent function and knowing how these things move allows us to make it neater. We call all of those things transformations. So moving it around means to transform it. Transformations using the vertex form.